Well, hello everyone and welcome back to Adrian's Digital Basement. On today's video, I'm going to try to repair this TRS-80 Model III motherboard. I've had this motherboard for a while and I tried to repair it once before and it completely stumped me and I wasn't able to fix it. Now this was before I was even making videos on YouTube and I hadn't learned a lot of what I've learned since that point. So I'm thinking now I have a better chance of actually getting this thing working this time. So without further ado, let's get right to it. Before I get started with the repair, let's talk about my test setup a little bit, because normally if you're working on a TRS-80 Model III motherboard, you need the computer sort of split open with the monitor and all that stuff. Not exactly ideal for doing repairs if you don't have a lot of space like me, but also not great for someone trying to make a video about it, because then you're recording the screen with the camera and all that kind of ridiculousness. So for this setup, obviously I have the motherboard here on the bench and I have it connected to both power supply and the video goes to the RGB to HDMI. First, let's talk about the power supply, and don't worry, it's unplugged currently. So this is an actual TRS-80 Model III power supply out of a machine, and I had a couple of these because in my TRS-80 Model III upstairs, both of the power supplies didn't work originally. The thing just appeared totally dead. So I actually removed them, and this is one of the two, and I replaced it with an ATX power supply. To get this power supply working, all I had to do was replace this one capacitor right here. So that cap is what powers up the switching controller. I know you can't really see it due to insufficient light. There's a tiny little package right there. It looks like a transistor, but that's actually the switching controller that runs this entire switch mode power supply. And that cap there is its power supply. It's a very common part to fail because it's typically near a giant power resistor, which is this green one right here. It basically takes line voltage, like the mains line voltage, and it slowly charges up that capacitor until there's enough voltage in it that that little power supply controller thing can start running. And then once that is running, it takes over and it's powered off of like the main part of the power supply, like from 5 volts or 12 volts or whatever. Because the cap is critical for the thing even starting, and it's right next to a very hot resistor that's hot all the time, high usage power supplies often bakes that cap and it kills it. So yeah, I swapped it out and this power supply immediately came back to life. Because the original wiring harness for the power supply to go to the motherboard is still in the computer upstairs, I had to just make a new one, so I just did that right here. Luckily on the power supply in the corner there, it actually has the voltage outputs, and of course I tested that with the multimeter just to make sure. I did hook up also an LED right here with a resistor, so I could tell when this thing is running, since of course it's open and it's dangerous. There are high voltages, as it says right here, while this is running, mains voltages and things. So do not touch this, of course, while it's powered up. And for the last little thing, I had this, it was off like an old Macintosh or something. I cut this out to size and I added little plastic standoffs so that the high voltage on the bottom of this board is not just touching the desk right here. It actually sits just like that. The power cord I made is this one, and it goes into this connector right here, which is the power connector for the motherboard. Beware that the pinout is slightly different on this than it is on the power supply. It's like reversed actually. Before powering this up, I used continuity check to make sure that the 5 volts from the power supply was actually showing up on the right pins right here on the RAM, which is not installed at this time, along with the 12 volts that also shows up here. The negative voltage is negative 12 out of the power supply and is regulated down to -5 volts onto the motherboard with a little tiny voltage regulator here. It's just a bias voltage, so it's super low current. That's why you just have a tiny little voltage regulator here. But I was able to find the -12 volts that comes in the power cable on one of the leads on this little regulator that's right there. Now, of course, that totally sorts out the power. Now, next up is video, and I didn't want to have to lug the monitor down here. I wanted to hook it up to the RGB to HDMI, which is sitting right here. And I know it's difficult, I keep talking about this thing on my videos. It's very hard to get them right now because the Raspberry Pis themselves are nearly impossible to get. This is running on an original Pi Zero, but it does work with the new Pi Zero 2, I think it's called, which is $15 if it's in stock, and it never is anywhere. Anyhow, on the Model 3 motherboard, this connector right here next to the power connector is actually for the video output. And you can check in the Radio Shack service manual for the pinout, but I've written it down on this post-it note just for my help. It's connector J5, you have a video signal, vertical sync, horizontal sync, and ground, of course. If you download the latest firmware packages for the RGB to HDMI, there is already a Model 3 and a Model 1 profile in there ready to go. Someone else has obviously done this work. Actually, the funny thing is I hooked this thing up to the motherboard and I created my own profile and I saved it, and then I went to go add it into the main profile directory as opposed to the saved profiles, and then I noticed the real one was there. Oops. For connecting it to the RGB to HDMI, I go from this pin header here, and I had created this a long time ago. It goes to a 9-pin, and on the side right here, I had written the pin out, like what color means what, like vertical, horizontal, stuff like that, going to this 9-pin connector, which goes into the RGB to HDMI. So I'll be capturing the video of the RGB to HDMI through OBS here. I have the oscilloscope, which will be capturing as well, along with a service manual, which I'll have down here. And that should be it. That's how I'm gonna do my troubleshooting. Okay, so here is the motherboard. So we have the Z80 CPU right here. We have some Rom chips. This is the character generator ROM. We have RAM, which would be installed, but because I had tried to fix this in the past and I couldn't, I just removed the RAM. It's 4116 to use elsewhere. I thought this motherboard would be sort of a goner, but in the end, obviously, hopefully we're gonna try to get this working. So I will have to reinstall some RAM there. We have 2 expansion headers down here on the bottom. I can't quite remember what is what. I think the one on the left here is like a parallel port, like a printer port. And this one is a bus connector, like an expansion bus connector for hooking up a external hard drive, things like that. And then there are 2 expansion connectors up at the top here for plugging in like these clip-on boards, which I think there are some holes here, here, and here that basically hold those in place along with being pushed in there. And there's some holes there for whatever, little clips and stuff like that. Pretty sure one of these is for a floppy drive controller and one is for a serial card. The TRS-80 Model III works perfectly without a disk drive controller and becomes like a cassette system for saving basic programs onto tapes and stuff like that. Now, if you're familiar with Model 3 motherboards, you might be thinking there's something wrong with this particular one. It's missing a couple other parts besides the RAM. And yeah, it's these cables here. So for whatever reason, when Tandy designed this thing, they needed you to install these ribbon cables on the motherboard. And let's see how this one goes on. This one goes, let me find where it goes. Wow, why am I having trouble here? Well, this one goes, there are 2 connectors here and here. So that goes in that position. Ah, yes, okay. And then this cable goes from here to there. Now, unfortunately, take a look at this one. See how it's a blue color? It should not be like that. It should just be a silver color. That is corrosion. This thing has corroded so badly, I don't think this is actually gonna work anymore. This smaller one is only partially corroded. See, the blue is on the ends there and also on these outer traces, but this inner part looks okay, and the other side is the same thing. So let's take the multimeter on continuity mode. Just double check it is. And let's just see if any of these are actually making contact through. Okay, it actually is making contact. Let's just see if all of these are working. Yep. Yep. Okay, well, as shocking as this one looks, it is actually working. Now, I assumed these weren't working, and it was gonna be my intent to actually just, on the back of the board, create bodge wires to connect these 2 connectors together. I was just about to go plug this in, and I noticed it's all delaminating here, which I think is exactly why it's getting all corroded. And this is also a common problem, by the way, on the Model 1. The keyboard connector uses this same exact kind of ribbon cable, and it totally falls apart. And just toning this out from this side of the connector to up here, definitely this connector is connected directly to this cable. And let's see over on this far side here. Yep, also this one is the same thing. Okay, anyhow, both of these are fully functional now, so these cables, as bad as they look, they actually work. I've been talking a lot about this motherboard. Let me actually power it up and let's take a look at what it's doing right now in this current state. All right, so there's the output. As you can see, it's just a bunch of garbage. Now, because this particular motherboard uses TTL logic for display circuitry, it doesn't use a CRT-C chip like the later PETs as an example. It doesn't require that the computer actually be operating and running code out of ROM to initialize the display. The display will initialize no matter what's going on with the CPU. You could remove the CPU and it would still actually display information. These two chips right here are 2114 SRAMs, which are going to be the display buffer. And as I said, that this is going to be the character ROMs. So I'm sure if I remove the character ROM, we're just going to get a full white screen, but we can tell that it's working because all the characters look correctly formed. And then the static RAM here is currently not initialized, so it's just displaying what's in these chips. As an example, I'm just going to unplug that, turn it off, and I'm going to take one of these out. And let's take a look at what happens to the display. So there it is. Notice that the characters are no longer formed properly. There's a bunch of question marks. And that's because with this chip out, things are just floating now. And the character ROM doesn't exactly know what to do with that or whatever buffer chips there are. So that is completely normal and expected. I think if I removed both of the chips, we'd probably get a full screen of just mostly question marks. All right, so we're approaching a system that is not working. This is the equivalent of a black screen on a Commodore 64. What's the first thing we check? Well, power, clock, and reset signal, and that's on the CPU. So let's do that now. All right, so the CPU is up here, the Z80 CPU. Let's see what we're looking for. First, let's check out 5 volts, pin 11. All right, we're getting 4.82 volts, which of course is exactly what I expected because I already tested the power supply and the 5-volt rail on the chip is just connected directly to the power supply. Next up is reset line. Now, when you have a line over it here or you have a slash in front of it, that means that that signal is active when it is low. So when the pin 26 is held at 0 volts, that means that the CPU is in reset. So when you turn on a computer, you should see that low for a split second and then it should go high to indicate that the reset circuit has started execution or is telling the CPU to start executing. Plug it back in again and we should see it stay low for a second and go high. Okay. There we go. So that's normal behavior right there, low then high. Okay, next up, clock signal, and that's gonna be this little symbol right here, pin 6. Okay, this is what we're seeing. We need to zoom in because it's gonna be high speed. And there it is, frequency of 2 megahertz, which I'm pretty sure is exactly what the TRS-80 runs at. So at this point, it seems like the system should be at least trying to run. So what it should be doing at this point is go to the reset vector, which I think on the Z80 is all zeros, and that should select the ROM, which will then start reading back code onto the data bus and then basically start executing code. You don't need the RAM to even be working for that to work. So we should see something happening on the data bus and on the address bus on this CPU. Let's take a look. Okay, so what we are on right now is pin 30, which is an address line 0, and that looks like absolutely normal activity right there. Well, let's just go through the line here. That's address line 1, 2, 3, 4. I'm just going through all of these and they all look fine. Nothing weird, nothing stuck in like the middle or stuck high or stuck low. We're seeing normal activity on all of them. All right, so I checked up to address line 10. That looks fine. Let's try the data bus now. That is data bus line 0 on pin 14. So I'm just gonna go through them again, make sure that everything looks good, and it does. That looks like normal activity. We have a 5-volt line in the middle, which is what we got. 6, 5, 3, 4, and then we have the clock signal. Okay, data bus lines look good, and the address lines look good. So the CPU is trying to do stuff. Now, of course, there's no RAM in this thing, so it's not likely it'd be able to really do anything. Like, it's not gonna clear the screen. We're still gonna get that garbage. I think what I wanna do is take out the Rom chips. That should cause the data bus just kind of get stuck, like maybe float even, and the address bus should just sit there because the CPU is trying to execute and it's not getting anything, or who knows what it's gonna do. It might act weird. So I'm just gonna write 1, 2, and 3 on these so I can keep them apart. I always draw a little arrow just so I know the correct orientation of the chips. I put them back in correctly. So, to be honest, I don't know if these ROMs even work. And when I was troubleshooting this thing, I'm not sure I actually had replacement ROMs to even test, or so it could well be just one of these ROMs is bad, and that might be the entire problem with this machine. I don't think I did much troubleshooting taking that working motherboard and swapping parts with this bad motherboard to try to figure out what the problem is. But we'll see if we can do that. Maybe I'll get the Retro Chip Tester Pro out and we'll see if these ROMs are working or not. Okay, so I powered up the board again, and now we're looking at address line 0. It's just sitting there with a perfectly repeating pattern, which definitely indicates the CPU was running code before, and now it's just sort of not. And I'm looking at address line 1, it's the same. Address line 2, same. It's sort of stuck. Yeah, this is kind of normal behavior. The CPU is just not able to do anything. And looking at the data bus, same thing is going on. In fact, it's kind of at 3.9 volts, sort of floating. And that's because the ROMs on here were pretty much the only thing that were driving the data bus, because the CPU is trying to read out of the ROMs, and then the ROMs need to write what they have in their contents onto the data bus so the CPU can execute it. So that's why we saw activity on the bus. That was coming from the ROM chips. And now we're not seeing anything because the CPU is not writing to the bus, it's reading from the bus. And because it's floating, it's not going to get anything useful. All right, I know we have a really small window here, but I am looking at the service manual, and these are the 3 ROM chips in the machine. I can see that one of them is a 2K by 8, and the next one is a 4K, and then there's an 8K. Okay, and there's actually a hint on which is which. So this one says 316B, 332, and 364. This one here is the 8K, this one here is the 4K, and this one here is the 2K. And according to the schematics, the 2K goes into is that a 106? Because this one is in U105. And U106 is that one there. And then, yeah, that one goes here, this one goes in there. So they were definitely in the right position. Now the thing is, when we looked at the oscilloscope, we saw that the ROMs were definitely doing something, because if they weren't being selected, like say the select logic was bad, then what would happen is you would still see floating data on the data bus. Probably one of these is used for like initial booting of the system. There's probably a basic ROM, and then I don't know what the other one does. So whichever one is used for booting the system, that one needs to get selected by the TTL logic on here for selecting the chip, and then it does that reading from it. Well, we saw activity on the bus coming from the ROM chips, so we know for sure that something is being selected. There could still be a problem with select logic. I'm gonna kind of go towards that maybe the ROM chip is bad. So I think what I'm gonna do is break out the Chip Tester Pro. And actually, I just had a thought. You know, there's no RAM in this system, so like I said, it's not even gonna execute. I'm just gonna pause right here. I'm editing the video, and I noticed that I keep talking about the fact that if there's no RAM, the computer is not really gonna run. And the reason for that is most 8-bit processors just don't have a lot of registers. So there's a lot of pushing and popping to the stack, which is part of system memory typically, that is used to temporarily store registers and allow subroutines to work. Most code is written in a way that requires a stack to work, and for the processor to have a working stack, you have to have working system memory that is used for the stack. And you might be thinking, maybe this motherboard works. I can tell you that it definitely doesn't, and the RAM that was on here, the board was working exactly like this when I first tested it a few years ago, and with the RAM on there, it did the same thing. And I took the RAM off and I used it somewhere else because I thought maybe the RAM was bad, so I tested on another machine. It didn't improve the situation at all. So I don't think it's actually getting to the point where it's either initializing the video. Could be a problem with the CPU talking to the video RAM, actually. That could well be a problem. But I think I need to do 2 things right now. I'm gonna get the Retro Chip Tester Pro, see if these ROMs read properly, and then I'm gonna put RAM in this thing, and we're gonna see what that does. As you can see, this one says 16B, so we know this is like a 2316 type ROM. But there's something very interesting that you have to consider. The pinout of the 2316 and say the 2332 and 2364 is somewhat standardized. But what's not standardized between the different ROM chips is what combination of select lines need to be enabled to read out the ROM. And you can definitely come a gutser, as Dave Jones from EEV blog says, if you try to read this incorrectly by using, like, say, the Commodore way of selecting ROMs may not be the same on the TRS-80, and you will get a blank ROM back. Okay, so we're gonna pop this one, the 16, into here. And if you notice, there are actually two 2316s, an A and a B, and I'm assuming there's a slight difference in pinout. I don't know what's what, so let's just start with the A one. Now, here's the active state thing I was talking about, and this thing has an auto detect mode, which you get to by pushing that button, and now it says jump to detect, so I'm gonna push jump, and there it is. It says not possible. I think that means that it can't figure out how to read this, so I hit the reset button to get out of there. All right, so let's go to the B one, and here it is. These are the active states again in different lines. Commodore, Apple II, and then auto detect. So I'm gonna hit the select on there. Okay, there it is, I figured it out. Low is 18 and 20 and high is 21. With that combination, the chip is outputting valid data or some kind of data. So it thinks that is the correct select logic for that chip. I think that happens to match what Commodore does, but even Commodore is not consistent from one chip to another. So again, be very careful with that. All right, so we're gonna hit okay. It's gonna read the chip, it's gonna calculate it. On the SD card, I have the index file, which, see, that's interesting. It should have read that, I think. Try that again. Okay, 2316, is this in there correctly? Make sure it's in there. Jump to detect, there it is. Now we're gonna read it. Okay, so the index file, which I think you saw pop up there for a second, is the MAME database of like all the ROMs that are in MAME and the CRCs that are for all those ROMs. So you stick in a ROM chip like a Commodore VIC-20 kernel ROM, and it will say VIC-20 kernel on the screen there. Let's try a different one because it shows that CRC there, but it's not giving us the TRS-80 thing there. Okay, so this chip here is the 2332. So we have to exit out of this and go to that, which is this. And let's see, auto detect. Not possible. Oh, because the chip is only half in the socket. Let's try that again. Okay, there it is. So low is 20 and high is 21. Let's see what that gives us. Aha, look, TRS-80 Model III. So this 32 chip is actually reading. And in fact, there is the file, so U105, that would be like what it's called on MAME. If we just move this for a second, this would have been the middle one. Yeah, U105 there. Okay, so I'm gonna draw a tick mark on there to say that that chip is probably good. Not 100% sure that it's good. The Retro Chip Tester Pro is not perfect at testing things. It doesn't load the outputs the same way as the computer, but at least it's able to read it and it sees it as what it is. This is the next chip here. This is the 64. That is from the socket over. So we're gonna go to 64 and it's a 24 pin one. Oops, 24 pin. Let's see, does this have an auto detect? Yes, it does. There it is, low is 20. Let's read this one out. Okay, there it is, U104 Model 3. So this one, I'm gonna draw a tick mark on it. That one looks good as well. But let's go back to this one here and let's auto detect. Okay, there it is. We'll read that. Oh wait, there it goes. Why wasn't it reading properly? That's weird. So is the chip marginal? I mean, certainly looks good. It's from 106. Let's try again, because the thing is, it may read one time properly, but maybe it doesn't read multiple times properly. So let's do this auto detect again. Hit OK. Okay, it's working. So maybe that was just a glitch in this or something. I am not quite sure about that. Okay, so after 3 reads, that chip seemed like it was good. So I'm going to say that all 3 of these ROM chips appear to be good. Now, it's not for sure, but the fact is they give the checksum. This thing is very useful for that. Now, I could have easily read it out myself, done a checksum. Maybe that MAME database, I assume, is available on the internet somewhere and you can find the checksums. I don't remember where I got it. I think the creator of this thing had a link to it that I just downloaded, the whole like little database that's on the SD card. So there should be a way for you to at least dump the ROM with a regular EEPROM programmer if you create an adapter to do that, and then find the ROMs for the Model 3 and then compare them. You know, use a hex editor or whatever, compare the 2 files, and that would be probably one way to also see if they were good. But of course, thanks to Stuart who sent this in, this thing speeds that up a lot. All right, so I think I need to stop dorking around here and actually just put RAM in this thing, put the ROMs back in so we can continue troubleshooting. All right, the RAM is all installed. Unfortunately, only this RAM is tested good and the Retro Chip Tester Pro. This other stuff I just had. I found that this RAM is relatively reliable, and when I find bad chips, I always throw them away. Or they're in the dead parts bin. So let's power this baby up. I put the ROMs back in as well in the correct spot. Let me just double check. Is everything, yeah, everything is facing the correct direction. Okay, here we go. All right, well, we're getting a little bit of a difference here. So now we're in 80 column mode. So TRS-80s, both the Model 1 and the Model 3, because they're both the same really, have both 40 and 80 column switchable. Now that the RAM is in and the ROMs are back in, and it's switched into 80 column mode, because before it was 40, that actually implies something to me. That implies that perhaps the ROM is executing code right now, and like it's looking for a keyboard, input or whatever, and it is able to command the display circuitry to 80 column mode. Well, it's not 80 actually, it's like 32 and 64 columns, I think. I kind of have a feeling now that maybe the problem is actually the CPU talking to the display memory. Because if you think about what happens when you turn on a computer, very first thing that happens, it does some bootstrappy stuff. Eventually what happens as it executes ROM code, and it's using the RAM to do that, what it needs to then do is clear the display memory, erase it, fill it with spaces basically, which is the equivalent of erasing it, and then put the welcome message. If the CPU is not able to write to the display memory, which is these two chips right here, well, that's not going to happen. But the computer might be actually executing and working normally otherwise. I think one thing we can do to see what's happening with the RAM is to just look at the RAM chips here and see if it's writing to them. So here is RAM on this particular motherboard right here. And notice here on this first chip here, we have RAS, we have CAS, and we have a WR pin. That's the write pin. If it's actually writing to memory, then I'm gonna go out on a limb and say that the ROMs are actually running. So I'm on pin 3, and I don't know if that's a correct write signal. I mean, it's this bouncing up and down is just because other stuff is happening, but it's not writing to memory right now. All right, let's change the trigger mode to falling, and I'm gonna switch this to normal mode, which means it won't show anything until it actually gets triggered. So if I unplug this, notice there it showed something. So when I plug it in here, it looks like it was writing to memory. Let's do that again. Power cycle it. There it is. So those are all writes. You see all this up here? It was actually writing to memory. It was doing it in like bursts. And then I guess what happens is once it gets to like a cursor prompt, maybe it's running ROM code, like it's waiting for keyboard input, and there's no more RAM access at that point. Okay, so definitely it's writing to memory when it powers up, which would be normal. It's probably doing like a little bit of a RAM check or whatever. And then it sets the display to 80 columns, which again, I think is something that's happening because the ROM is actually executing. I think if I pull these out, that won't happen anymore. So the next tactic is let's go to the schematics and look for the display circuitry and try to figure out how the CPU is able to write to display memory. All right, so this right here is the video output. There's the sync output. This is really hard to read, right? This is a 74LS166. This right here is the character ROM. So this is cycled through to display the characters. So around here somewhere, we're gonna find the video memory. Okay, here they are, 2114s. They are 4 bits each. There are VD7s. Here's the data bus that goes to the video memory. We know these chips are good because it's currently displaying memory out of them. That's what the garbage is on the screen. And when I pull them out, remember we're seeing those question marks. That implies that definitely those chips are, well, I mean, at least they're being read out by the video circuitry, and that happens automatically. But right here, U67, this has gotta be, it doesn't say what China chip it is, but it has the VD lines on one side and it has the D lines on the other. Here it is right here, 74LS645. I gotta look up what that is exactly. All right, so it's a bus transceiver, but what exactly is different about this than the 245s that we normally see? It's a bidirectional bus transceiver, 20-pin package, that's all pretty normal. Let's bring up the LS245 to compare. So this is the LS245 data sheet. So there's the direction pin, output enable. I mean, this is all looking very similar. All right, so propagation delay, 15 nanosecond versus 12. Volts the same. I mean, current drive, it's all similar. I'm very confused. It literally doesn't look different to me. Well, back on the schematics here. So whatever, this chip here, pin 1 is the direction signal, VRD, so that's the direction signal. And VRW, this is the write signal for the memory. Let's look at where those are coming from exactly. Or you know what? Why don't I scope those signals and let's look at what that looks like. Okay, so there we go. Pin 1 on the 645 here. It's changing direction quite a bit. And then this is the enable signal, and it's also active quite a bit. That chip is being seemingly instructed to turn off and on, so it's like doing its thing. So why don't we look at this write signal on the video memory? Because of course there's a flashing cursor if this thing is actually running, which should indicate that it's updating video memory. Okay, so on the video RAM, on the write signal, that's definitely not writing. So I'm gonna do what I did before, switch the trigger mode to normal, and we're gonna power cycle this, and we're gonna look to see if we see any writing to the video RAM. No, there is no writing going on here at all. Okay, I'm making a lot of assumptions here. Like I'm making an assumption that the computer is actually working, like it's running, like it's even trying to clear the memory. So what do I do here? Let's see, what do I do? Let's see. What I need to do is find out where that signal is coming from and then try to look at the circuit to see, like if it's a logic chip that generates it, which it will be, what conditions are being set to generate it. Maybe I can probe the other pins to see if that chip is just bad and not actually outputting the write signal. The schematics here are not helpful because everything here, like see these arrows point to things that go elsewhere on the thing and there's no lines and it's really not helpful. So VWR, I have to kind of look through everything here. It's gonna be an arrow pointing out because see how it's like an in arrow there? It's an out arrow, so I gotta look at all the out arrows here and find where that is. Well, I just had a thought, I still haven't found that signal, but I did find in the address decoding page the keyboard signal. I think this like goes to the keyboard. There's probably some ICs on there to basically read from the keyboard. Let's take a look at that pin. I don't think it would be doing anything if the computer weren't waiting for keyboard input. This is just going to try to validate my hunch that the machine is actually running. We're gonna go to U60, I think that's a 60, and we're gonna look at pin 6. And as this IC right here, it looks like it is the correct 145. So we're gonna be looking at pin 7. Oh, it's confusing because look at this, 0, 1, 2, 3, 4, 5, 6. This is actually the decoded signal and that is the pin number. So it is 7. Okay, I'm not seeing anything. Let's power cycle the computer. Yeah, that does not look quite correct. And if we change it to single, nothing. There's nothing happening on that pin. What about these other signals here? So I'm checking the inputs here. So I'm on pin, that is pin 12, which is the D input. Pin 13, there's activity. 14, 15. So we're getting activity, but it doesn't look like any of the outputs on this chip are actually doing anything. I mean, that doesn't look right. This chip might be bad. No, all of these, this chip is selecting things and it just, those outputs don't look correct. Let's look at this little neighbor here, which is similar, not quite the exact same thing. But if we scroll over, we can see that this is also selecting like, well, there's like ROM A, for instance. So we look at pin 12, or yeah, pin 12 on 58. So there's pin 12, and you notice there's quite a bit of activity on it. Looks normal for like selecting the A ROM chip. But then this comes out, and this is like a little cascade selector thing, and then this using some address bus input here is supposed to select these other chips right here, and it does have pull-up resistors. ROM B is all of those. C, keyboard and video. So, I mean, could I have just stumbled onto the bad chip accidentally? But one thing is for sure, if we look at the schematics here, you see this vid signal? that is probably necessary for any kind of activity to the video circuitry. So for like writing to the video circuitry, that probably needs to be low or high or whatever, probably low, because this has pull-up resistors. See, pull-up resistors right here. So vid needs to go low to select the video circuitry. And if this IC is bad, that's not gonna happen. I'm thinking that these little drops here are it trying to drive it to ground and not working. So look, it's trying to select things. So I am gonna say right now, this chip is bad right there. Now, the funny thing is, you saw it was trying to drive it to ground, but it didn't look like it was able to. So what I'm gonna try to do is I'm gonna try to find another one of those chips and I'm gonna piggyback it on there. Because basically, if the chip I piggyback on is able to drive it to ground, this bad chip's not gonna do anything. It's kind of like dead there on the board. And maybe this thing will come to life. Let me go find a TTL chip. All right, so the bad chip right here, this is a BCD to decimal decoder. So I'm just gonna put that chip right on top there. I've just piggybacked it. And let's take a look at this pin here, which I think is pin 8 for the video. All right, so I'm gonna keep my finger on the chip here. I'm gonna plug in the machine. And let's take a look at what we see on the output. Well, would you look at that? That is very different. And let's switch over to the HDMI and we're getting nothing. That's interesting. Why are we getting nothing? Let's unplug this and take the chip off and see if we get the garbage again like we should. Okay, there it is, garbage. Now let's put that chip back on and we'll plug it back in. Well, we don't get garbage, but we're not getting anything. That well could be because it's trying to boot a floppy disk. Do you have to basically hit the break key to get to the basic prompt on a Model 3? I don't really remember because there's obviously no keyboard hooked up and we don't have a disk drive hooked up. I think before I grab a keyboard so we can do some more testing to try and break out of this thing, let me replace this chip. I can't believe I just stumbled onto it. Pretty hilarious. All right, there it is, a socket. There's the bad chip removed from the motherboard and there's the replacement. So let's pop this one in and see if we have a nice working machine. Of course, I'm gonna need the keyboard, which I have grabbed as well. All right, here we go. I'm gonna plug it in. Oh, we have garbage. That is interesting. So that implies that was not the fix. Okay. Well, that's so weird that when the chip was piggybacked, see when I plug it in, there was 40 columns for a second and then it went to 80. What did I do wrong here? Let's get the scope. First off, let's check out the input. So I'm on 12, that's 13, 14, and 15. So inputs all look good. Video output, pin 9. Okay, there it is. So that definitely looks a million times better than it was doing with that other chip. I wonder why when I piggybacked this bad one on, well, the good one on top of the bad one, that we at least had a black screen. Wow, that's kind of disconcerting. Well, let's look through these. So pin 1 is ROM B. Oh, that's interesting. It's not really dropping down. Okay, let's look at ROM C, which is 4 and 5. Same thing. And then pin 7 is the keyboard. Well, it's not doing anything, I guess, because it's not looking for the keyboard. And then we have the video, which is working. All right, well, let's see here. Let's pop this one out. This is the new one. And the original chip is back in. Okay, we're not really seeing anything now on any of these pins. Let's recycle the power again. Okay, wait a second. So that is the video output. And then there is the ROM B select. And yep, it's doing the same thing. So maybe I accused the chip of being bad when it wasn't. Now, okay, we're getting garbage with a little bit of static. Okay, what I want to do is replicate what we had happen the first time when I piggybacked the good chip on top of the supposedly bad one. Okay, it's piggybacked and we hit the power. So that was like some kind of a red herring. Okay, so I just tried something and I took the chip out, both of them, and now we're getting 40 columns. So it's not even going to 80 column mode. So that's interesting. So I don't think this chip is actually bad, this 145 that I took out. Luckily it's not damaged and should still work in the motherboard here. Alrighty, so definitely this chip is not bad. I don't know why it looks like that on its outputs, the only slight decrease. And I also don't know why when I piggybacked it originally, it did result in a black screen. It's very confusing to me. I mean, it was pretty clear. I'm pretty sure I did it, like put it on, it was black, took it off, it wasn't, put it back on, it was black again. And now it's not doing that. So it's all a little confusing to me. All right, lots of time has passed and I've been doing lots of troubleshooting off camera because at this point, I don't really know which direction to go. There's a few things that I figured out since I turned the cameras off to do some troubleshooting. First off, this ribbon cable here is pretty important actually. This connects the data bus between the CPU and its buffer and a lot of the other components, including the video circuitry. So with this out of there, the video circuitry can't possibly work. But I did double check that I'm getting connection from this side, which is this buffer chip, over to the buffer chip here that's on the RAM circuitry. So this is a good connection, this thing. There's a set of jumpers on the board that are for whether you're selecting like 4 or 16K RAM chips, things like that. I went in and double checked that all of them are set correctly, and they are. I took out all of the additional RAM, so we just have 16K in here. This is the first bank up here at the top though. And what I did is I double checked that these 2 extra chips here worked. I checked them in the Retro Chip Tester Pro. So all of these are known good chips. There's a ribbon cable coming off the board here. This is actually an IDE cable because I couldn't find the original cable. But I do have the keyboard for the computer. This is a Model 3 keyboard. I just had a spare one in my storage bin. And yeah, this is so I could push the reset button to help with troubleshooting. I learned that the 74LS 645s, where there were 3 of them, one here, and one there, are the same as 74LS 245s. And in the service documentation, it actually calls them 245s. So clearly those are interchangeable parts. I have the 3 645s here, which all test good in the Retro Chip Tester Pro, but they get hot when they're running. I kept touching them with my hand and I was annoyed by that. So I put in modern chips. These are modern versions that just don't get hot. And lastly, on the schematics, I was looking for this write signal, video write, and I don't know how I missed it, but it's generated right here by this IC. There it is, video write, and there's video read. It is kind of interesting on these 2114 SRAMs that the chip enable line is grounded, which means these chips are always active. But you have this chip here, which is one of those 245s or 645s, and the video write signal, or video read signal, I'm sorry, is what connects these to the actual data bus. And when I say data bus, D0 through D7A is this side, the left side of this ribbon cable. This side is without the A, and this side is with the A. The ribbon cable that goes up to this side here is the B cable, like data bus B. And from what I can tell, it is only used for these 2 connectors here. But basically, I've been going over this board, reading through the theory of operation for the machine, checking everything, and nothing really makes sense to me. What is happening is things are kind of inconsistent. Now that I have a reset button on the keyboard, sometimes I push the reset button and the screen flickers a little bit. It's still garbage, but it flickers a bit. Sometimes I push the reset and then it does nothing. I can look at the various signals on some of these chips, like the video read and the video write, and depending on which reset cycle I'm in, sometimes there's no activity on those, and sometimes there is. So things are just weirdly inconsistent. Besides swapping out those bus transceivers, I did double check that these video RAM chips work, but I mean, I know it's not that. I did swap out a different CPU, and that didn't make any difference whatsoever. So it's not the CPU either. So this has all kind of led me down the path that maybe this ROM chip is bad. Now, while it tests perfectly in the Retro Chip Tester Pro, maybe when it's tested at speed or read at speed by the CPU, it's not really returning the right results. I'm not sure. And remember when I first showed on camera in the Retro Chip Tester Pro, this was actually not reading correctly. And then it just started working again. So the fact that things are just inconsistent when I hit the reset button, like the states of the machine, the various state machines on here just seem different every time. That screams that maybe the ROM is not working. So what I went ahead and did is I built an adapter. I happen to have some of these PCBs, and it goes from a 2364 to a 27128. And there's actually a jumper location right here that allows you to select between 2 different images in here. So you could have 2 versions of the ROM. And I figured I'd need to build one of these anyways because I'm thinking that the next step for this machine or this motherboard is going to be maybe trying to write a diagnostic ROM that's gonna do something like it will do a little RAM test, or maybe it will just immediately start writing to video RAM over and over again. And it just can let me validate, what's going on exactly. I don't know. To test that this actually is wired up correctly, because I've never used one of these, I put this into the Retro Chip Tester Pro, which happens to be sitting right here. Is that going to focus? And that is the reading. It actually read it out as the correct ROM. So I know that this is working as a 2364. So I haven't tried this in the machine yet. Alrighty, there we go. I'm pretty sure that if this is installed in the motherboard, due to the stacked nature of it, I can't install the RF shield that is in the actual machine. The motherboard will fit without a problem. I don't think there'll be any issue without the shield, but definitely with the shield, I think that's gonna be too tall. Okay, moment of truth, I'm capturing video. Let's see what happens here. No change. Okay, so, and see when I hit the reset button, occasionally the relay, which is this little blue thing here, goes like click, click, it makes weird noises. The whole computer is just not happy. Something is going on here that I am just struggling to find. I don't think anymore that this machine is actually executing code properly. Well, it's starting to boot, clearly, but I don't think it's actually getting to like a basic prompt that I just can't see. The states of all the various signals are too inconsistent to really be a working machine. Something is causing this machine to not work. All right, there it is. That's the TRS-80 Model III repair video. That was not a repair. I got stumped once again, so I apologize for the unrewarding video. I figured I'd leave it in though, because I wanted to show that the trials and tribulations of trying to repair a board like this, it's just natural to go down various paths. Unless you're super familiar with the way it works, like I am with Commodore 64 as an example, it takes a lot longer for me to kind of digest and try to break down and reverse engineer from the schematics the way this thing is supposed to operate. Now you can imagine if you're working on an unfamiliar board for the first time and you don't even have schematics, it can be very, very difficult to try to even figure out the problem. But even when you have good schematics like I do in this case, and I even have like theory of operation and stuff like that that's in the service manual, it still didn't result in a working board. But don't worry, I have some more ideas, and I'll be taking a break between the repair sessions, and I think sometimes that's what you need to just sort of clear your mind and start again from a better perspective on things. I think I was going down some of the traps, so that the wrong paths I was going down the last time I repaired this board, even though it was years ago. And I think I just need to kind of like clear my mind and start again, which I'll be doing in the next video. And I guarantee you, I can't guarantee 100%, but I guarantee you that almost certainly I will have this board running in the next video. And no, I have not recorded the next video yet while I'm doing this outro. So if you enjoyed watching me flounder around not being able to fix this board, thumbs up, but if you didn't, you know what to do. Subscribe if you haven't already, check out the second channel if you haven't already, and thanks to my patrons. I really appreciate their support. You can do so, you can become a patron down below if you feel like it, and that is gonna be that. So stay healthy, stay safe. I will see you next time.